Hi, welcome to Coding Off Work stream. Before we start, we once again would like to we want to thank. We have had our sponsors speakers on. That's why I think we should talk to them, but not because they're sponsoring us though, because they're awesome. And so our sponsor, which is Progress Telerik, because they have amazing Blazor UI components. And last time we checked, they have over 85 components.
That's amazing. That's a lot.
It is. Chances are they have what you need.
Mm-hmm. So we will link that in the chat as well.
Definitely.
If you're seeing this on YouTube, please follow us on YouTube. The alert thingy down here. Just click it and you will get notifications whenever we post a new video.
Definitely. But we have a guest today.
Mm-hmm.
We do. We have Daniel Roth. Welcome.
Hi.
There you are. How are you?
I'm doing great. How are you two doing?
We're doing good. Yes.
We have a heat wave. We talked about that. I heard that.
Yeah.
You got it a little bit warm in Seattle as well.
We hit over well over 100, like not even just a little bit, like 108, 109, which in the Seattle area is unheard of. I think we've only had over 100 degrees. This is Fahrenheit, by the way, people who
otherwise we would be boiling.
Things are melting. I think we've only had that happen like 3 times since like the early 1800s in the Seattle area, because the ocean usually keeps us cool, but for whatever reason, the right parameters, maybe a little global warming thrown in there or whatever, like really spiked us into the 100 range. And we don't have air conditioning here. No one, I don't have. We have a little like wall units and stuff like that, but not central there. So it was hot. It was hot.
Yeah. And we're usually joking that Seattle has the same weather as back in Sweden because we have a lot of rain and it's never sunny and all of that. But we didn't want your heat wave.
Yeah. Well, it's not just us. Like I think a lot of people hit a lot of heat this summer. Got warm.
Yeah, definitely.
Always something to complain about in Seattle, whether it's rain in the gloom, or it's too hot, or it's too
humid,
cold. Like, I grew up in the northeastern part of the United States, in Massachusetts and New England, and so we had all 4 seasons. Got the cold in the winter with the snow and ice, and the hot and humid in the summer, and so we got all the spectrum. And I came out here and. People here are a little more sensitive, a little more tender to the temperature changes. Yeah. It's nice though. It's
you call that cold? That's not cold.
Yeah, I know. Exactly.
That is true. Mm-hmm. And we also have some news, don't we?
Yeah.
Because your book came out.
My book came out, and this is going to look really funky on the green screen.
It will,
because it is green.
It is.
And it has raccoons. Look at that. Raccoons.
At least we can see the raccoons.
The book is transparent.
I know, right?
It is. It's a feature, not a bug.
Now, chances are that this is the only Blazor book with the raccoons on the cover.
Pretty sure it is. Blazor raccoons! Look at that. Yes, exactly. We should make that a thing.
That's great.
We're not here to talk. Thank you.
Again. I know getting through a book. I've never had to write a full book before. I can only imagine that was a hard labor to get through.
It was, and it was also so satisfying because I learned so much. I mean, you know you know how to do things in Blazor, but if you're writing a book, you really need to deep dive.
Yeah.
And suddenly,
you should be giving this.
I'm
gonna move out Jimmy. Like, you can correct me on all the things that I'm misrepresenting.
No, but it is a lot of work. I watched him write it, and there was a lot of profanities that didn't make the cut, the book. So that's good. There also was a lot of good things, though.
Yeah.
Actually. Getting to know how everything is connected, that's cool.
It was way more work than I thought it would be. But a lot more fun as well.
So
Heard
there's
from
that.
A lot of book authors, like it was so much more work than they originally thought.
Yeah.
I actually got a LinkedIn message from another publisher saying, "Oh, would you like to write a book for us as well?" And I'm like, nah, no.
I have one Blazor book.
Yeah, let's just give it a couple of weeks at least.
This is my life's work. I can't top
Let
this.
me
This
at
is
least
where it is.
forget how much work it was before you ask. But it is a good book. I was one of the technical reviewers. So if he can teach me to write a freaking blog engine, I think it's pretty good.
Nice. I'm gonna have to read it. I'm gonna have to take a look.
Yeah.
Some Blazor.
But you didn't like my favorite chapter. What's
Her favorite chapter was a JavaScript Interrupt chapter. What's up with that?
It was super interesting.
I know, right?
It was interesting.
I mean, you're also like, oh man, the COM interrupt in .NET, that's just my favorite thing. And like the whole world. I would sit there reading those docs and at that time I'm lying in bed reading about comment. Yeah. That's great.
We're not here to talk about my book. We're here to talk about Blazor, the new stuff.
Yeah, .NET 6 just arrived.
It is coming.
Well, it is coming.
In pieces. Every month.
Yeah, exactly.
A new installment. It's like better than Netflix. Like there's a new payload that arrives with new features and work. Yeah, we're past that halfway mark now. Marching to the final release in November. That's when .NET 6 will ship. And I think we just shipped Preview 6. So that happened yesterday. So if you haven't had a chance to check that out, go check out the blog post. Go download it. Give it a spin. File issues on GitHub. Tell us what you like. Tell us what you don't like. Also, it's sim shipped with an update to Visual Studio 2022. Visual Studio 2022 Preview 2. Is what came out on the same day, and it includes .NET 6 Preview 6 in the box. So if you've already installed the Visual Studio 2022 preview release, then you got the latest .NET 6 bits as well.
Nice.
So those are marching together, which is great. Lots of new tooling features happening on the Visual Studio side as well. So yeah, it's coming. We're over halfway through. So Preview 6, I think the plan is there'll be one more preview branded release, Preview 7, and then a couple of release candidates in the fall, at least if you're in the northern hemisphere, and then November. November is when it's supposed to be ready for production. I mean, some of those release candidates, in the past, I know we've said that release candidates have go live, like are go live releases that if you want to put them in production, we'll support you with that. I don't know if we're doing that this time around, but that may happen as well. So look for those release candidates too. That'll be a good time to try out the bits if you haven't tried out .NET 6 yet.
You have never listened to that anyway. You were in production
I usually
day 8 of Blazor.
I usually listen to the Go Live license. That's good.
Did you with Blazor? Well,
we weren't in production. There were 8 days after the general availability. So
you were working with it since the day you could get your hands on it, so you could get it into the production.
That's true. That is true.
If it works for you, scenario.
Well, it's been really, really working really, really well. Nothing has, and no major issues at all. And you've been running in production since, like I said, day 8.
Yeah.
Wow.
Which is pretty amazing. So well done.
There from the early days. Yeah, I remember. Yeah. Good stuff. Good times.
Yeah. So should we take a look at next steps?
Yeah, let's bring in the slides.
What is coming? What is happening in .NET 6? I'm gonna look specifically at the Blazor features. There's lots of stuff coming in .NET 6, way more than we could even cover in the time that we have allotted for this today. So make sure you go and check out all the things in ASP.NET Core, Blazor's part of ASP.NET Core, so this is just a piece of that. But all the stuff in the .NET runtime, frameworks, .NET MAUI, all these things are coming in .NET 6. But today we're going to just look at the new Blazor features, because that's what I work on. I'm a program manager on the ASP.NET team, and I specifically handle our Blazor development as well as some of our other UI investments in ASP.NET Core. Do some work with MVC and get my fingers in other places as well. But mostly Blazor these days is what I'm doing. So we'll take a look at all the new stuff. If you haven't been keeping up with .NET 6, this is a kind of an interesting release for us in that it's a very open planning process. Like I think in previous .NET releases, we would talk amongst ourselves. We'd look at what people are saying on GitHub and come up with a plan and then unveil it to the world and say, this is what we're doing. We've tried to be much more transparent and inclusive in what we're doing in .NET 6 from the beginning. Part of that was defining these high-level themes for .NET 6 and having them published on the themes of .NET site, having them published publicly on the internet. The main themes for .NET 6, they're pretty broad, like making it easier for new developers to get started with .NET, expanding support for building cross-platform native client apps. .NET MAUI is what that one's all about. Ensuring that .NET has everything you need to build apps that run natively in the cloud. Ensuring that enterprises that are using our long-term support releases, our LTS releases, have a really nice, smooth upgrade path. We were just talking about breaking changes are kind of a thing of the past, hopefully, mostly. I mean, we do some targeted breaking changes still, but we try really hard to make our .NET releases as highly compatible as we can so that you can just keep accruing value from the platform as it moves up. You just float with it. Upgrades should be as seamless as possible. We're doing work to strengthen the .NET ecosystem. We're making development with .NET faster and more productive. We'll see some of that today. And then we're just also this broad bucket of meeting developer expectations is basically finishing work that we've started in previous releases, like in .NET 5, stuff like single file publishing and linking and such. These are longer lead efforts, making sure we're delivering on your expectations as a developer for those features based on how we originally pitched them to you all. Now you can, this website is public, so if you want to go to themes of .NET, this is the actual site right here. So themes of .NET, and these are all.
Yeah, we put that link in the chat as well, so it's easy access.
So all the high-level themes are here, and you can drill down into these and look at the different epics and user stories that make up each of these themes. If you're a Blazor fan or a ASP.NET Core fan, there's this. That work is kind of spread out across multiple themes. So to make it easier to find, we created this high-level roadmap issue on GitHub that kind of collects all those issues together. So you can just click on that, and that will take you to this roadmap GitHub issue, which has all the stuff we're doing in ASP.NET Core, and of course Blazor, because Blazor is part of ASP.NET Core. So here's all the links to the GitHub issues for what we're doing in .NET 6. This site, of course, is a Blazor site, so that's cool to see. We're using it ourselves to run the release and manage our processes. So that's how you can find the ASP.NET Core roadmap, just themes of .NET, and you can see all the individual GitHub tracking issues there. So what is coming in Blazor in .NET 6? Lots of stuff. We're not going to have time to cover everything here, even with the time that we have, but I will try and cover the ones that are in bold, and then a few extras, a few bonus ones at the end. .NET Hot Reload, we'll talk about the ability to really quickly make changes to your running app, apply those changes while the app is still running, while keeping the state of the app without losing any app state. State persistence during pre-rendering, we'll look at that. Error boundaries, WebAssembly ahead of time compilation for much better runtime performance for Blazor WebAssembly apps. Done a lot of work to decrease the download size of Blazor WebAssembly apps in particular. We'll look at Blazor hybrid apps or .NET MAUI Blazor apps. That'll be at the end. Custom event args, required parameters, and a whole bunch more stuff that's still also coming that you can, I'll let you go look at the roadmap to learn about these things. We are getting to that painful point in the release where we're getting near the end, and we had all these ambitions and aspirations of all these things that we hope to do, and reality starts to sink in, that we might not get to everything. So in previous presentations, I had this entire bulleted list. The ones that are sort of grayish are looking like they might fall below the cut line for .NET 6 just because of time and resources. We'll see. We'll do our best, get as much stuff in as we possibly can, but that last batch at the end might not actually make it.
Well, I for one, rather wait until they are ready than get crappy ones. So I think this is a good call.
We try to maintain the quality bar as opposed to just shipping the feature as a broken or half-baked thing. And then it's also important for like we talked about compatibility and breaking changes. We don't want to ship something that turns out like the API shape isn't quite right, and then that creates a compatibility problem for us in the future. So we try to hold stuff back until it's really ready to go. That last batch might not be quite but we got a lot of stuff.
We have a question for you, actually.
Go for it.
Regarding this, where is the developer productivity improvements? Debugging, live reload, and hot reload. Well, hot reload is on the first line, I think.
That is the first one. .NET Hot Reload is a big one. And that is actually where we're going to jump into first in just a second.
Awesome.
Let's see, was it live reload is something that I'm not sure exactly what that one's referring to. That might refer to the previous workflows we had where we would like restart the app. Like we would do a full rebuild and a full restart of the application on file changes and then refresh the browser for you. Kind of more of like an auto restart feature, I think is how I've referred to that one in the past. That's still there and that will continue to be there. We actually use that a little bit in conjunction with hot reload to smooth out the developer experience. And debugging, lots of debugging improvements actually are coming in .NET 6 that aren't on this slide. Like more of the debugging features that you expect to work with .NET debugging will continue to light up in the Blazor WebAssembly debugging story. I think there's debugger display attribute is one of the attributes. I just got an email from the runtime team that they have that out in PR to add it to the stack, so you can use the custom displays for debug for values while you're debugging. So things are also getting better in that space as well.
Nice.
Let's take a look at them.
Yay! I agree.
Developer productivity improvements. Let's see. Okay, so let's take a look at Hot Reload. So this is an app that we built a while back that is kind of like a little mini picture editing app for doing image processing. It's a Blazor WebAssembly application. And as you can see, I've left myself a little to-do here to actually show the pictures. It doesn't currently show any pictures. And to do that, I'm just going to go into the code. Here's the Razer code for that part of the application. And let's just change this text. List images after work. And I'm just going to save. And I'm going to actually start the app again because it wasn't actually working. There it goes.
Well, we are live, so something is bound to go wrong.
Oh my goodness. Hold on. Let me restart this. Let me restart this application. So what I'm doing behind the scenes, just so folks can see, this popped over here, is I'm actually running this app using .NET Watch from the command line. And why is this guy showing up? That should maybe go full refresh. Okay, great. We're back and working. Okay, so behind the scenes, what I'm doing is I'm actually running this app using .NET Watch. You can see it right there. And so .NET Watch is a tool that you can run on any .NET project, really, and it will watch the files as they change. And as you save them, it will kick off a rebuild and restart the application for you. But in .NET 6, we've added support for .NET Hot Reload to .NET Watch. So you can see that right here, it's saying that Hot Reload is enabled for this app. So we're running. And so that means .NET Watch, when it sees file changes, it's actually going to try to apply those changes directly to the running application while it's executing without having to restart it at all, which is really, really fast. And I'm doing this with .NET Watch right now. All the functionality that I'm showing you is making its way into Visual Studio. In fact, if we look up here at the top, there's this button here that's grayed out right now that says Apply Code Changes, and you can barely see it, but it's a little flame. It normally shows up red if you're running under the debugger. That's the like apply a hot reloadable change to the app in Visual Studio, and it is there. There's some issues with it right now with Visual Studio 2022 Preview 2, where it's not quite working in particularly with Razer scenarios. It'll like apply the changes, but it won't actually refresh the browser and show the new pixels, that type of stuff. Those are all things that are being ironed out in Visual Studio 2022. So like Preview 3, I'm hoping that will be the release where we can actually start showing this whole hot reload flow using just the Visual Studio set of features. But for right now, I'm going to do it with .NET Watch. Okay, so let's do this again. I'm going to add some code here and save, and that should just change. And there
we go.
Yeah.
Awesome. All right, and it's really actually fast.
It's so fast.
For reals. Watch this. I'm going to hover my mouse button. 1, 2, 3, save, and it's like almost instantaneous.
I don't even understand how this is possible.
Well, it's some clever runtime stuff. So we're calculating these little IL diffs for the code that's been written to figure out exactly what needs to be changed in the running application. And the runtime has capabilities where you can say, please apply this little delta to the running application while it's running, leaving any state that you have in memory untouched. So that's why it's so quick. If you've used edit and continue in the past, it's a very similar set of capabilities that this is being built on. It's just a much more fluid developer workflow. You just edit your code, you save, you see it in the running app immediately. That's .NET Hot Reload. Now this is obviously just like a markup change, but we can do fancier things. Let's actually add some code in here to show the full list of images. I'm going to add a little for each loop, and we'll format that so it looks nice. And ready, 3, 2, 1, save. Boom! Almost immediately.
Yeah, this is insane. I don't know what unicorn tears you found, and I agree with this person. That is going to make design so much easier instead of using the developer toolbar and stuff like that. It will just update instantly.
I mean, my day is basically half my day is spent waiting for Visual Studio to start over again, compile, start up a web browser. What am I going to do for the whole day?
Work?
Write more books. Yeah. It's a lot of fun to work with. So, and by the way, this is not just Blazor. Like this concept of .NET Hot Reload is coming to all of the UI workloads in .NET 6. So if you're building Razer Pages apps or MVC apps and doing CSS/HTML, it works there. If you're doing desktop application development, MAUI development, XAML development, Hot Reload is coming to all of those workloads in as consistent a way as we can make possible.
Yeah, and we got great news about this. Blazor developers really need some dev experience as they have in React and Angular and all of those. And this looks really good.
And this is just a piece. I'll show you some more stuff later in terms of just developer productivity. We're doing a lot of work in the Razer Editor itself to actually make it easier to write your code. But this is certainly a big part of that story. I want to explain a little bit about what's happening here in this code. So we have this onInitialize method. If you're not super familiar with Blazor, that's the lifecycle method for a component that happens when the component is initialized and set up. And we're doing an HTTP request back to the server. And this is a Blazor WebAssembly project. So it's running in the browser. It's making an HTTP call back to our ASP.NET Core backend to pull down some JSON data and deserializing it as an array of editable images. And then we're just looping over all those images and rendering this image list item component. So here's one of the, I think this works, productivity improvement. I could just F12 on this or go to definition. I think this also works. Yeah. So go to definition now works in Razer with component files. That's a new Razer Editor feature. You can see that right now, all this component is doing is just rendering a div with the current image name. Nothing too fancy. We can start adding some more markup in here to actually show the image. So here now we have a div with some classes. This is using Tailwind Css. I know Tailwind can be a little controversial. You know, some people love this model, some people don't.
Yeah, we just had our last stream. We had Ed Charbonneau on talking about Tailwind and CSS and all of those.
pros, the cons of this model.
Yeah, mostly cons, I believe, in this case, but okay.
But that's
in Ed's case, but mostly
personal
cons. Yeah,
preferences.
Absolutely.
We did try to keep it somewhat informational as well, but it was very interesting though.
It was.
For me, the point here is that Blazor's based on HTML, CSS, open web tech. If you can use whatever CSS framework you'd like. We typically use Bootstrap in our default templates. That has its pros and cons as well. You can use Tailwind. You can use raw CSS. It's all just open web tech underneath the covers. Nothing proprietary.
And that's basically what we came to the conclusion. It's basically the same thing under the hood, so it doesn't matter what you choose.
So here now we're actually going to render the name of each image and also an image tag using the URL for that image. So I'm going to, again, 3, 2, 1, save, and this shows up. Changes.
This annoys me because you changed a component that is used on the other Razer component, not the
actual component.
Yeah, and it just worked.
Well, they're all there. All the components are there. This is a whole tree. You can poke in at any part of the tree, make a hot reload here, mess with this component there, hot reload that there, and it will you'll interact with. I believe it interacts with the Blazor renderer to make sure that it just re-renders the part of the tree that was updated by that hot reload. Now, I don't want to bore people by typing a whole bunch of Tailwind CSS and potentially offend all the people who prefer raw CSS. So I'm just going to copy in a bunch more markup that makes it look nice and pretty. So we got all the images now showing up. All right, so that's hot reload with markup changes, including Razer syntax. Like you can do Razer syntaxes for hot reload. You can also do hot reload with just your C# code. Like if you're in a CS file, you can change that too. In this case, we have this humanized last modified method. This is just a C# method that lives on the component class. Everything in this code block, you can think of that code block as just tacking on a bunch of code onto the generated class for this component. Every .razor file turns into a C# class at the end of the day, and the code block is just adding a bunch of members and methods to that class. So humanized last modified is being used right here to generate this green text at the bottom, like when the image was last updated. And we can change this too. Like if we want to say, instead of updated, let's change this C# string and say that this was changed. 3, 2, 1, save, and then just goes all the way through the app. So you can modify all your C# code, hot reload that into the app, no problem. That works as well. The last bit is CSS. So if you're dealing with your styles, like a very common pattern, right, is you go into the browser and you mess around with the browser dev tools and fiddle with the styles and get that code back into your CSS files.
And then you forget something.
Yeah.
And you have to do it all over again. You mean that?
yes, exactly that. With CSS hot reload, we can make changes to our CSS files, and they will get pushed into the running application and applied to the live DOM for us. Where should we do that? Let's do it in the...
That will make life so much easier.
I wanted to do the layout, I think. Yeah, main layout. So here's an example of a component-specific CSS style sheet. So this is just a normal CSS file that's been scoped to this one component, to main layout.razor. You use this file convention to do that. And here we've got some CSS variables that we can mess around with. This is sort of the theme color for the app. We can change it to red. Let me change that, and now it just propagates all the way through. If maybe we want .NET purple because Blazor's all based on .NET, and so you can make changes to your CSS files, and they'll just get pushed into the running application as you're doing that. It works with normal, like top-level CSS files as well as component scope CSS files.
Perfect. So will .NET 6 also be available for Visual Studio 2019?
No. It will not. Yeah, so we're like, there's a bunch of things that are being done in the tooling in Visual Studio 2022 that will be needed for full .NET 6 development. MAUI development will require it. Like there's compiler work and such. Like the .NET 6 will require VS 2022, and it will ship with VS 2022. So it'll be in the box. So once you get the new tooling, you should be good to go with .NET 6 development. So yeah, you're going to need to upgrade. Start planning. Start planning now. All right, cool. All right, next feature I wanted to show is error boundaries. New feature in .NET 6. So error handling in Blazor today is, it's just C#. So, try catch, right? No problem. Add enough try catches and you should eventually have all your errors handled. But the feedback we got was it's a little clunky. It's a little hard to sort of centralize what you want to do in the event of an error. Can we do better? So error boundaries are a way, they're components. An error boundary is a component that can capture unhandled exceptions from the component tree and then allow you to react to them however you like by rendering custom content. If you're familiar with React, I think React also has a similar concept. We take a lot of inspiration from the JavaScript ecosystem when we do stuff in Blazor. So if you're familiar with that feature, yes, it is inspired by that feature. So let's introduce an error. We need some error that we can play around with. In this humanize last modified method, I'm going to go in here and just throw an exception. Format that nice. Okay, so if the image ID happens to be 1, then we are going to throw an invalid operation exception. I think that would be this happy kitty down here. Yeah, that is number 1. And so if I save this, then we should. What happened to my .NET Watch? Are we still running? Yeah, we're still running.
Come on, kitten.
What happened? I have to refresh. This one? No. Ideas one. That looks
it's
right.
It's because Kitties doesn't throw exceptions. They are just awesome altogether. You should have put it on the dog.
Still in preview.
You need to throw a catastrophic error. Then it...
You went there. Catastrophic.
All right.
Yeah.
There we go. I don't know why that didn't. That should have hot reloaded and resulted in an exception, but it didn't. But as you can see now, I'm getting the normal Blazor editing error experience, where this is the yellow bar of death, right, of Blazor. Some handled exception occurred and took down the app. If we go into the console, we can see there's our exception. Boom, invalid operation exception. But we can use error boundaries to handle this exception in a more reasonable, more scoped way in our application. And the way you do that is using a new component. So let's go here. Around our image list item component, that's where we're throwing the exception. We're going to just add an error boundary around that. So here we go. And I'm going to, hopefully this time, if I save it, is that going to work? No, that's the browser. Save it. Let's see. It is restarting. Okay, good. So now, if we look at our kitty has disappeared. Yes, the kitty has disappeared, and it's been replaced with some error content, some error UI content. Now, where's that error UI content coming from? Well, what a error boundary does is if everything's good, it will render its child content, which is the inside of the element. If an exception happens, then by default it'll render some error UI, and then you can customize that. So if we look at what that default error UI is, let's go and select that red box. And it's just a div. Like that's all that the error boundary will render when an exception happens. It's just a single div with a particular class. And so then you might wonder, well, where's all this like red and yellow stuff coming from? Well, that's just some fanciness with CSS, like in the CSS style for the app. We have this some styles assigned to that particular class to give it a background color, give it an icon. Even the text is being added all with CSS. By default, all you get is a div. So we can do better than that. Like we can actually customize what UI you get from the error boundary. Let me show you what that looks like. So that looks like this. Okay. Okay, so now what's happening here? We have our error boundary. We have the child content. We're explicitly specifying it this time. So we're saying we just want to render the image list item. And then we have what we want our error content to be in the event of an error. And here I'm rendering my own div with a crying cat. And you get an exception. If you want to like mess around with the exception message and so forth, you can do that. It's passed in as a context variable. So if I save this, and this change is not a hot reloadable change, so that's why it's taking a little longer. It's actually doing a full restart. And we get our custom UI now for that particular error boundary. So that's what error boundaries are.
We have a question about that. They are awesome. Is there an API for it to catch the error?
to catch the error? Well, you get the error handled to you in the error content. So this context parameter, you now have a sort of a ambient variable called ex, which is the actual exception. So you can then, like the error boundary itself is catching the error and then giving you the exception to decide what to do with it. There is also an API where you can then like reset the state of the error boundary. Like once it gets into this state where an exception has occurred, from then on, it will continue to only render error UI forever until you tell it to stop, until you tell it to reset. There's an API for doing that as well, that you can, like if you're, like maybe you had an error that happened when you were like browsing away from a page, browsing to a particular routable component, like to a page, you can hook into the error boundary to say, reset yourself when you've navigated, because when I come back, that exception might not happen, and I still want you to try and render the real content, stuff like that.
Can we log exceptions?
Can we log exceptions? So there is a logger. We use the same iLogger abstraction in Blazor that we use in all of ASP.NET Core. So you can get that as a service and log. More interesting question is like, what do you want to log to? So like there's no built-in logging provider that's going to pump logs from the browser to some external store someplace. So that part you'd have to do yourself. But yes, you can plumb into the iLogger abstraction to log exceptions.
And we also have another question. Within the error content, can I check for type and things like that?
Yeah, that's a great question. I mean, you get the instance, right? So you have an exception instance, so you can do anything with that instance that you would normally can do with any .NET instance. You can check its type to do particular things based on the type of the exception. But it's a little different than like having a type-based catchphrases in a try catch. So you just basically get an exception instance that you have to decide what to do with. All right.
Awesome.
That's
some good questions.
Yeah.
Good questions, everyone. Let's look at state persistence and pre-rendering. All right, so do that. I'm going to remove my error here. Let's go back and get rid of this.
Back with the kitty.
Okay, back. I'm going to get my cat back.
The big question is it even a demo if you don't have a cat? I don't know.
The demo worth watching. Yeah. The app restarts are sometimes not catching, so I'm just having to do a manual restart. There's our kitty back. Okay. Now,
it's a really good demo because it's catching the error.
Oh,
did you?
Snap.
I'm sorry.
Did you?
I'm sorry. I could say I'm going to stop, but we both know I'm not going to do that.
Are you not going to say anything to bridge over?
Ooh, nice.
To something else now? Yeah.
I totally dropped the ball on that one.
2 thumbs up. 2 thumbs
Catching.
up. All right.
We need to go to the next step, I think.
Okay. This app is Blazor WebAssembly, so it's being rendered client side, and we can see that by looking at the actual source for this page. Like here's the source. Pretty bare bones. Not much here was actually downloaded from the server. We got the head, we got a body that has basically nothing in it, other than this weird comment that's like a placeholder for where do we want the Blazor rendered stuff to be put. But then client side in the browser, Blazor kicks off it renders the components and it inserts that content into the live DOM. But the original download from the server, pretty bare. But sometimes we want to do better than that, and we want to actually have content come in that initial request. That's better for things like SEO. It's better for anything that requires static analysis of the page. It's good for getting pixels on the screen faster. How can we do that? Well, the nice thing about having .NET on both sides of the wire is that we can pre-render our components from the server. We have an ASP.NET Core backend. It can run .NET code. It can run Blazor components. Let's run the Blazor components first from the server, put that into the page, and then we'll fire up Blazor on the client once we've got everything down client side. So we can do that very easily. Let's go into our server project. And the thing that's rendering this page initially is this host CSS HTML file. And this is just a Razer page. This is server-side rendering of HTML. Blazor does client-side rendering of HTML. And you can see right here is where we're putting that marker about where do we want our Blazor app to be rendered. We're using the component tag helper to do that. And we're saying, please render this app component. And right now, the render mode is just WebAssembly. Like, do everything client-side on WebAssembly. But we can change this to be WebAssembly pre-rendered and save that. And that should work. Let me make sure that that's actually going to get picked up by the app. See the file watch kick in there. So, some bugs. I'm just going to restart it manually. And then let's see what we now get on the source from the server. So great. Okay. So now if we look at the source downloaded, we got all the divs and images stuff being rendered server side first so that they show up much quicker on the client, and search engines can see all this content and so forth. Unfortunately, it doesn't quite have the user experience yet that we might want. You may have seen it when the page initially rendered. Let me open up a new tab and I'll browse to the app again. Now watch carefully. So we hit the server, we immediately get the content, and then poof, it just like disappears. And we see that loading spinner, and then the content comes back. Why is that? The reason why that's happening is because when the Blazor WebAssembly app loads client side, it has to go get the image data again. The image data was retrieved on the server for the initial render, but then you have to get it again client side because nothing transfers that state to the client. And while in order to do that, it has to do an HTTP request. Let's go look at the code for the index component. Here's our index component, right? And when that component gets initialized, it does that HTTP request that we saw previously. While that HTTP request is doing its job, actually, while this whole onInitialize method is doing its job, the index component just renders a placeholder. It renders a little loading spinner. And we're exaggerating this a little bit. You may have noticed there's a 2-second delay so that you can really see that loading spinner. Most of the time,
wouldn't recommend that.
No, don't put delays into your app. This is just to prove a point. Most of the time, this problem shows up as like a flash. Like you set up pre-rendering, and then it pre-renders great, but then there's this like flash while the app loads client side.
You wonder if you actually saw the image render or not.
Or you're like, are you glitching out? Was that my screen?
Yeah.
What was that? So that's what's happening. That's why you see that flash. But we can fix this problem now in .NET 6 really easily by doing state persistence into the page from the server during pre-rendering. What does that mean? So, we have a new service, and it's called Component Application State that we're going to add to our index component. There it is. We're also going to implement Idisposable. I'll show you why in just a second. And what this service allows us to do is to hook an event so that we can persist state during the pre-rendering process. And that state will get persisted into the page so that it can then be picked up on the client so that it doesn't have to go and get it again. It already has the state that it needs, so it can do basically a no-op render at that point, and you don't get the flash. Just use what was rendered initially from the server. Now, to use this service, we're going to need to change our code to non-initialized. That looks like this. All right, so a little bit more going on here, but not too bad. I'll walk you through it. So non-initialized now, we're using that component app state service and hooking this on persisting event. And there's our persist image data event handler. When we get notified, we call this persist as JSON method to say, I want to put a little bit of state. Please save this for me. I want to give it a name. It's preloaded image data, and here's the data I want to serialize. Basically, like a JSON payload. Then we pop into our normal uninitialized logic. We're going to check first to see, is there already state here that I can use? If there is, we'll use it. If not, then we'll issue the normal HTTP request that we were doing previously. And then at the end, we're implementing dispose so that we don't accidentally leak these extra event handlers. All right. Now, how does the state actually make its way into that pre-rendered page? If we go back to the page itself, host.css.html, you may have noticed there is this other tag helper, the persist component state tag helper. That's what's going to put the whatever state you wanted into the page so that it can be retrieved from the client. So let's go ahead and save this and see if my hot reload's going to kick in. We'll restart. And let's see what we get now. There it goes. Okay, so if we go look at the source, we see our pre-rendered content as before. That's good. But now at the bottom, there's this new fancy comment called Blazor component state. That's where we're serializing the state that you had on the server into the page so that it can be retrieved client side, big old blob in there. And if we now go to the app and do the same trick we did before, where we open a new tab, it just loads.
There we go.
Refresh, refresh, refresh. It loads fast, loads clean. That's how you can handle that flashing issue and take advantage of pre-rendering in your Blazor WebAssembly apps. And Blazor server apps too. You can all this issue is less common in Blazor server, but you may also hit it there as well.
Awesome. So we do have a couple of questions for you.
Go for it.
Does WebAssembly pre-rendered work without ASP.NET ASP.NET hosting?
No. You need a host. You need .NET code on the server, and so you need something that's going to be able to take your Blazor components and run them. And where we have that logic is in ASP.NET Core. It's important to remember that Blazor is part of ASP.NET Core. Like the component model itself is part of the ASP.NET Core shared framework. So they are integrated together. They're meant to be used together. Like you can see here, we're using Razer pages with Blazor all in the same application. That's very much intended. Blazor's not like a separate replacement or offshoot of our web stack. It's part of the integrated web stack. So no, you'll need an ASP.NET Core web host in order to do this.
Does this new pre-rendering seamlessly work with client-side SPA authentication? Because there are some issues today.
There are still issues.
Authn.
Not yet.
Yeah.
That is a known
Not
issue.
yet.
There's discussions on GitHub about what we want to do there. That's a problem. Like if you're doing authentication, pre-rendering is still problematic. That's an area we still needed to work on. Yeah, good question. Thank you for being patient on that one. We know that's a problem. Probably not going to happen in .NET 6. At least I don't think so. We'll see. I mean, there's already a bunch of stuff that we're scrambling to try and get squeezed in, but known problem. Okay.
I think we did get an answer to this one, right? Can't you just check if it was pre-rendered? And I think we got an answer to that.
Yeah,
and we do have a comment.
That was just my thought. I couldn't remember what name was. View state is view state.
Yeah.
Yeah. I mean, to be fair, to be clear, the difference here is this is only part of the pre-render. Like there's no like cookie that's like pushing state back and forth here. If you navigate away, can I do this? Let's go to one of these images, and then if I go back, well, actually that worked just fine. Should that work?
I didn't want it to work fine.
Come back. I thought that should show. Well, I guess maybe not. But well, the point is if you do a client side navigation back to that page where there's no longer that state being served to you nicely from the server, then you're going to have to go get the state again, and you'll see that the loading spinner should show up. I don't know why it's not showing. So, but it's not being flowed back and forth across all pages. That's a big difference between what we're doing and what you're doing with view state. And also view state is kind of automatic, whereas here you're being very explicit about what you want to put there. Don't put something in that component app state thing that you don't want there. You don't want it to be huge. Obviously, that'll impact your first load.
Do a reload on a non-navigated page or route.
Okay.
Let's try that one.
On a non-navigated page. Is that like this?
So the dog.
So we're here on the tennis player. I'm doing a reload, and if we go back to here. Yeah, still, I don't know why we're not getting that loading spinner. I thought that was maybe there's something fancy in Preview 6 that I don't know about. That's interesting. Okay.
Well, we tried.
Let's move on. Next feature is advanced feature. I wanted to talk a little bit about custom event args. I'm going to kind of go through this a little bit fast because this deals with JavaScript. Now I hear Justin loves JavaScript, and that you'll probably like this demo. But for those of us that prefer to avoid JavaScript, take heart in knowing that the scenario I'm about to show you is very advanced. This is for very particular cases where you want to interop with particular JavaScript APIs in a custom way. There are in Blazor, you handle UI events that get raised from the browser, from JavaScript all the time, like on click, on input, all those types of things. And there are custom events that you may want to be able to handle, and you can do that in Blazor. What's new in .NET 6 is that you can do that now with also having custom event args for those events. When you handle an event in Blazor, we typically give you an event args object that gives you all the data related to that event so you can interact with it. When you have custom events, there was a way to do that previously to tell the Razer compiler that you want to define a custom event or handle a custom event, but there wasn't a way to do custom event args, from my understand. That is now possible, and this app is doing that. For this image processing part of the app, we wanted to have a little canvas here that we can select parts of the application in order to do some like fancy image processing, like pattern matching. To show that, I'm actually going to make one little edit where I'm going to go to the client, and here's the actual editor component, this guy right here. And you can see in the editor component that it's registering an event handler for this on region drawn event. This is a custom event that's defined by the application. That event is defined in this event handlers.css file. The way you tell the Razer compiler that you want to deal with a custom event is you define this event handlers class and you put this attribute on it, and that will just work. That will work with .NET 5. The part that's new is being able to define a custom event arg type so you can get data from the JavaScript world into your event handler. Okay, so if I go back to the image editor, here's where we're handling that event, this guy right here, and I'm just going to comment this out real quick and save. So we're not going to do any image processing yet. So is that? I think that. No. Okay, no, we're good. Okay, so you can see we have a little. No, that's the bug one. I was trying to avoid that. Let's get this restarted again. Okay. So now, like, you can select parts of the image, and what I want is to get all the image data, and I want the points from these regions that are being selected on the image so that I can run some .NET code on that data, do some image processing. So that's what's happening here. In order to make that work, we do have to write a little bit of JavaScript code, and that, in this case, is in this. This is an interesting pattern. We have. Going on. There it goes. There's this edit image.razer.js file that's accompanying this edit image component. There's nothing fancy about this convention yet in .NET 6, but we are looking at potentially adding this as a feature where you can have component-specific JavaScript files in addition to component-specific CSS files. So that may come later in .NET 6. Not available yet, but this demo is kind of mimicking that. And most of this JavaScript code is just vanilla JavaScript. It's just dealing with the canvas and drawing those dotted lines and regions onto the canvas. But the interesting part is the on draw end code right here, where we're handling what do we want to occur after we finish drawing a region. And here at the very bottom, we're getting an image array buffer for the canvas data, and then we're getting an array buffer for the selected region. And then we're raising a custom event, this region drawn event using the canvas. And then you pass in this details object to say, what data do you want to push over into .NET land? And Visual Studio was not letting me resize this for some reason. There we go. So the way this works is that these properties, you can do it one of two ways. You can either just put data there that you want to be JSON serialized, and it'll get JSON deserialized in your event arg object. Or if you're really advanced, this is, I think, Jimmy, you were saying you've done some of this code where you can actually do unmanaged interrupt, where you pass like references to memory in the JavaScript part of the application and just pass that reference over to .NET Land so that you can operate on shared memory. It's a little bit more efficient. Now it's, we're talking about WebAssembly specific code here in a very advanced scenario. But that's what this one is doing. It's getting a direct reference to the array buffers that were extracted from JavaScript. If we go back to our event handler, here's our custom event args object, and we just are matching the names of those properties that you saw in JavaScript. So source image and source region, and we're getting this IJS unmarshaled object reference for that data so that we can then interact with it. So this is now possible in .NET 6. If this goes like over your head, you're like, whoa, that looks really fancy. I got unmanaged interop and I got JavaScript. I don't want to write JavaScript. Don't worry, you don't have to do that. But if you're doing advanced scenarios where you're trying to interact with native browser capabilities or JavaScript libraries where you need to surface event args, that is now possible. So I think we can even show that real quick. So that's actually working. If we go back to our event handler, let me add just a couple write line statements in here. All right, so now
I need to show you this, even if the question was answered, but love it. So at least 2 people, Jimmy.
So
at least 2 people.
Not there is unmarshaled interop. We do tell people that they can use it, and we will do our very best not to break it.
Thank you.
There are some aspects of unmarshaled interop that people are. I think that what that person is referring to is that we have some doc comments that like this API is currently still subject to change. Like in .NET 6, we are trying to pin it down to be something that you can really take a dependency on and know that yes, this is now official public API surface area. That's still a bit of a work in progress, so don't get too excited. But it's possible. There are some things that we're doing in Preview 7 where you should, instead of doing this dance with unmarshaled interop, you should just be able to pass the array buffer back directly, and we'll just give you a byte array, and we'll handle the unmarshaled interop under the covers for efficiently transferring that byte array into .NET code for you. So this code should get simpler in future demos where you don't actually need to do your own unmarshaled interop. But yeah, it's a known thing that the unmarshaled interop APIs are still a bit in flux. Okay, so I've added a couple.
We want it.
Okay, gotcha. Thank you. All right, so if we go back to the app now, and now if we bring up the console, let's clear that. And if we start picking up things, no, let's do a refresh. Start the application. All right, I guess got some issues to deal with the file watching in .NET Watch. I'm not sure what's going on there. So let's do this again. So if we go to the image and we go to the console, and if we select a section, you can see we're able to get the unmarshaled bytes from JavaScript and then display how many bytes that were actually received on the Blazor side. So that's custom event args for custom events. And yeah, unmarshaled interop is something that we are working on getting to be stable. Now, what do we do with those bytes? Well, we have this logic here for running a patch match algorithm on the images. This is the we've already had enough stumbles in this demo sequence that this will just seem like a drop in the bucket. But there's actually an issue with this part of my demo in .NET 6 where something's happening in the runtime where the image processing is no longer functioning correctly. I'll show you what I mean just for kicks and giggles. If you've seen this demo before, you'll know that this has worked in the past and it will work again. Unfortunately, for Preview 6, it looks like we have broken it. So if I go back to the tennis player, what you should be able to do is to select this ball, and then when I release the mouse, which I haven't done yet, the bytes should be sent into some .NET code, a .NET implementation of a patch match algorithm, and that should then should just disappear. Like we should be able to remove the ball from the image. That's not, unfortunately. Oh, I forgot to save. Yes, restart. Yeah. And what happens?
Well, it did disappear.
Well, it did. The whole image disappeared.
Let's see. There we go. So that's not what's supposed to happen. It's actually supposed
again. It did disappear.
The thing I will show is like usually what we do is we can remove this entire logo. I'm gonna unclick this, and the ball usually takes a fraction of a second. Removing that large section, this timing is still correct because it is still running the patch match algorithm. It's mangling the image for some reason that I'm working with the devs to figure out why. But it takes a little bit of time. Like it's not particularly fast in Blazor WebAssembly. Why is that? Well, Blazor WebAssembly runs on an IL interpreter-based runtime. There's no JIT. Most .NET runtimes, you have JIT-based execution, so you're turning .NET managed code into native instructions on the fly, so they run much faster. With Blazor WebAssembly, the WebAssembly standard doesn't really enable us to write a JIT. So we're just interpreting the code, and as a result, it runs much slower. But in .NET
Ahead of time.
AOT, ahead of time.
You're spoiling the reveal.
We also have a thank you for the demos on the open heart surgery. That's very brave.
Oh, no. Thank you for everyone's patience. Okay, so to use AOT, so there is now WebAssembly ahead of time compilation in .NET 6. What does that do? Well, we can take your .NET code at design time, at build time, and turn it directly into WebAssembly. Instead of doing it on the fly with the JIT, we're just going to do it up front as part of the publish of the application. And now you have a large WebAssembly bundle that you ship instead of a bunch of DLLs, and that runs much, much faster. It does have a penalty of being larger. Whenever you take .NET managed instructions, IL, and turn it into its corresponding native instructions, the IL instructions are actually fairly abstract. And so the native versions of those of that same logic tends to be more code, tends to be more logic. So going from managed assemblies to native is going to get bigger. So you are trading off download time, like load time performance for runtime performance. That's something to be aware of. In our tests, what we've seen is it's about a 2x size increase. So, you know, yeah, so apps will get a little bit bigger, but they do get much faster. I do have an AOT version of this application that will run the patch match algorithm. We won't be able to see the result, but we can at least see the performance of the result. So let me shut this guy down. So it was about like 3 seconds? Yeah, 2.5 seconds. To do AOT, just so folks are familiar with the process, you're going to need to install some extra bits into the SDK first. And they come in as a workload. This is a new concept in the .NET 6 SDK. There's this new command, .NET workload, and we can just list them. So these are like additional components to the .NET SDK that were a little too big, or they had their own sort of life cycles, a little too disruptive to actually throw into the SDK sink. So instead of making the .NET SDK like, 2 gigabytes of stuff, we have this new concept of workloads where you can optionally install additional parts of the SDK as needed. Blazor WebAssembly AOT is one example of this. MAUI is another example of this. Like all the stuff for Android and iOS. If you're not working with Android and iOS, you might probably don't want to deal with installing all those bits. In order to make that more convenient for developers, we model them as optional workloads. So to install an optional workload, you do .NET workload install. Let me make this a little bigger so you can actually see it. And then you just type the workload ID. Currently, the workload ID for Blazor WebAssembly is this one, which is huge and atrocious and long. No one's going to remember that. In Preview 7, this will get shorter. This will just be WASM tools. That will be what you need to install. But that's the additional piece that you need to set up your machine with in order to be able to do WebAssembly ahead of time compilation. I've already done that, so I'm not going to do it again. The other change you need to make is in your client app, in the actual Blazor WebAssembly piece, you need to signal that you want to ahead of time compile the application. You need to set run AOT compilation to true. Once you've done that, it won't kick in on normal builds. It will kick in when you publish. When you do a .NET publish, usually with a release configuration, AOT will kick in, and then you should sit back, relax, go get dinner, go watch a movie. It takes a little while. It's not a fast process to ahead of time compile your application. Like I think with this app, last time I had time compiled it took like 5-10 minutes. So it's not something you want to do in every single build. It's running the Inscription toolchain in order to using the Inscription toolchain in order to do the conversion from .NET code into WebAssembly code. Takes a little while, so that's why it's a publish time step. When you're ready to go, publish the app, and then it should work. I've already done that, so I'm not going to make you sit and watch 10 minutes of publishing. So I have the picture fixer. Go to my bin, release, .NET 6, Publish. Okay. And then picture server.exe. The server process isn't ahead of time compiled here. That's a whole separate conversation. This is just the WebAssembly bits that have been ahead of time compiled to WebAssembly. All right, so let's go ahead and run that.
Do you expect improvements on the resulting binary size and the build time for .NET 6?
For the binary size, yes. And I'll show some of the size improvements that we've made in just a second. For the build time performance for AOT, the main thing you can do is if you can reduce the amount of code that you're going to ahead of time compile, then it will not take as long. Right now we do everything. Like we'll ahead of time compile the whole application. We are looking to see if we can add some features where you can selectively pick parts of your app and say, I only want ahead of time compile this part, not the rest. That's really tricky to do because now you have like .NET IL interpreted code that's like interweaving with WebAssembly code. So letting people arbitrarily slice and dice what they want ahead of time compiled and what they don't is a hard problem. That's why we're starting off right now with just doing it all. But that would, of course, reduce publish times because you're ahead of time compiling less code. Making the tool chain faster is a little bit trickier because a lot of it depends on third-party components that we don't have a lot of direct control over. Like we're using Emscripten, and the LLVM is used under the covers there for a lot of the optimizations. LLVM is not exactly known for being a fast tool chain. So there may be some opportunities for us to engage with those open source ecosystems and see what we can do to speed that up. But that's a harder part of the problem to deal with. So we're going to try and make it so you can AOT less. Longer term, we'll see what we can do about speeding up the tool chain. Okay. So if we look at should be the AOT version of the app now. If we go look at what was downloaded from the app, this is going to look huge because this is no, actually this will look slightly bigger, not huge. This is still trimmed and all those good things. Let me let's see what we get. And the key thing to notice here, we got all the images. You will still see DLLs. But the WASM file, which is right here, you'll notice that has gotten quite a bit bigger. Like it's a couple, megabytes now. And that's because we've taken all your IL code and shoved it into that single .NET WASM bundle and then linked it all together into a single file. So we're not taking individual DLLs and turning them into WebAssembly bundles. We're taking all the DLLs and linking them into one WebAssembly bundle. And the good news
is still way smaller than Facebook, though.
Yes. Yes.
Let's see what this does now. And whoop. So 0.6 seconds. So you get about 5 to 10x perf improvement when doing CPU intensive workloads. Now it's really dissatisfying to not actually see any real results from this. I do have another app that I can show, which is this Conway Game of Life, which is like a grid automaton style application. Let me pull that up. So
this is going to do wonders for my ZX Spectrum emulator.
Yeah, I would say so. Because now it's a little bit too slow.
Yeah. Especially if I want to add sound as well, then I can't do it.
So I don't know if you've seen Conway's Game of Life, but this is a 100 by 100 grid of cells, and there's like some simple algorithm that you run over each cell to determine if it lives or dies. And it results in this like really kind of fancy motions and animations for the cells. With the interpreter, we're getting about, it's hard to see, but about 5 generations per second of being able to calculate through this entire grid. That's the interpreter version. If we switch over to the AOT'd version, it's this guy. Perf improvement here is not quite as dramatic as with the image processing because there's a lot more DOM manipulation going on here. But this will ramp up to like 10, 12, 15 generations per second once it gets fully warmed up. So, a 2x, 3x perf improvement here. The performance of this app is being much more dominated on the diffing algorithm as it interacts with the DOM elements, which has a bunch of JavaScript interrupt. But still, the idea here is with Blazor WebAssembly AOT, you get significantly better runtime performance for your applications at the cost of some load time performance and publish time performance when you're actually doing the publish of the application. So that's AOT. All right, and we mentioned like making apps smaller. The one nice thing about this toolchain that we now have for doing ahead of time compilation is we can leverage it to relink the WebAssembly runtime, whether you're doing AOT or not. So your app might not be using parts of .NET.WASM. Like maybe you're not using a whole bunch of globalization features or the debugger or whatever. Previously, we could do linking on the managed assemblies, like the managed code, the .NET code of the application, and trim out all of your unused C# effectively that you're not using in the app. And that actually has gotten a lot better in .NET 6. Like we're able to trim a lot more from the DLLs than we previously could in .NET 5. But even better, if you have the WebAssembly AOT toolchain installed, we will also publish relink the WebAssembly runtime itself and trim down .NET.WASM to be a smaller bundle. So things that really big wins there is if you turn on invariant globalization in the application, we can strip out a whole bunch of logic that's used for globalization concerns that if you don't need, then you can just remove it and get a much smaller app size. As an example of this, there's an app that I published onto, this is an Azure static site that Anthony Chu helped me publish. And this app has the, a Blazor counter. This is a full Blazor application. And if we go look at its download size, I'll clear this. R. Okay, so the whole app here is 1.1 megabytes transferred. I think a default Blazor WebAssembly app in .NET 5 weighed in at about 2.2 megabytes total. The equivalent app in .NET 5 is this is about 35% smaller than the same apps in .NET 5. So the apps are getting overall smaller in .NET 6. If you turn on AOT, they will get bigger, but you're at least doing a 2x increase over a much smaller initial starting point. So that's the good news there.
And if you're counting just the JavaScript on Facebook, for example, I think you're in about 15 megabytes or something like that. So just put it in perspective what we're talking about here.
Yeah. We want to keep things. We do want to keep things as small as we can. That's why we do this work, to do size reduction. One thing that people in the .NET community can do to really help here is making, if you own a popular .NET library, is doing the work to make your library linker friendly. There's now a whole bunch of attributes that and things that you can do on your library that allow the IL linker, the thing that strips out unused code, to be much more intelligent about how it handles your library. Actually, by default, if you don't signal to the .NET IL linker that your library is linker friendly, then it won't even touch it. It will just leave it alone. So if you want your library to work well in Blazor WebAssembly apps or other app models that need small app sizes, like all the mobile workloads, like they want to be small, you should do the work to make your library linker friendly. All right, I did want to show some Razer tooling improvements. Let me hop out of this project. Let's just create a new Blazor application. New Blazor server. And we'll do .NET 6. So Razer has a long history in ASP.NET. We've been using it for a while, and we have an existing Razer editor that we've been shipping for years that we had been, poking at and tacking things onto to try and make work with Blazor. It was kind of showing its age. It had some issues, performance issues, reliability issues, formatting. Oh my goodness! Like all the issues that people complain about with the poor formatting of Razer files in the old Razer editor. We have heard that feedback loud and clear, and so for actually the last year and a half, we've been working really hard on replacing the existing Razer editor with a completely new one that's based on a language server, the language server protocol. It's got its own language server that we can then reuse across our Visual Studio properties. So in Visual Studio 2022, you have the new Razer editor by default, like it's on, and it will be the default Razer editor when we ship Visual Studio 2022 and .NET 6 later this year. And there's a whole bunch of goodies now that are enabled there. We've seen a couple of them already. Like let's take a look at index.razer. So we already saw like go to definition. If you want to just hop to the definition of your components, you can just F12 or right click and go to definition on that component. So that now works. You can rename components in the new Razer editor. So we can F2 or call this, my survey, and then do that. And so that will also, not only will it rename the tag, it will also rename the component file so that it matches. And give it a second, it will finally recognize the component. There's some little performance here that's going too soon. There it goes. There's lots of work happening on performance in the new Razer editor. Actually, a lot of things are much faster in the new Razer editor than they are in previous incarnations. If you have
it's still 5 months out, so
yeah. If you have an unknown tag and you want to create a component from that tag, there's now code actions that you can use to say, please create a component from this tag, and we'll create my component for you. If you
I like this one.
If you have a component in a particular namespace, let's call this foo. So now this component will be in the foo namespace. If we go back to index.razer, so now that component's no longer recognized because the foo namespace isn't in scope, but we got code actions to add. To add using statements for the component. We can resolve these. There should be. I'll give it a second. Yeah. We can add using foo so that you get the using statement for that component. Same thing from C# code. Like if you have C# code that you're writing in your code block, like what would be an example? I don't know. Like if I put what's a good type that's probably not in by default? Network credential, is that one? Credential, can't type. And if I do this, yeah, so you get @usings also for C# as well. So we'll be able to add usings for those things as well, which is nice. You can rename things across files, even when they're closed. That all works. There's also this gesture. Like some people don't like the code block in the Razer file. They prefer to have it in a partial class, like in a code behind file. There's a nice code action here to extract block to code behind. So if you do that, we'll go ahead and set up the partial class for you with the code that you had added there in the partial class. So if you want to move stuff over really quickly, that's really easy to do now. I actually like the inline syntax,
So I'm on team inline. Do you have one that does the other way around, takes the code behind and puts it in the
other way?
Yeah.
I don't think we do. I don't think we have that refactor. Because we tend to do that by have it set up that way by default. So it's usually the opposite direction that
that's true. That's true.
So we have a couple of questions for you if you want to hear them. So we have, are there any plans for better HTTP context support in Blazor?
That's a great question. So HTTP context is used to give you context about the requests, right? Like it's for, in an ASP.NET Core app, a request has come to the server and you want to do something with it. And the HTTP context allows you to get the request, the response, deal with headers, HTTP, all those types of things. Blazor is meant to be a client-side UI framework. It's very analogous to like Angular or React. Like you're conceptually running client-side in the browser. Now, you might say, well, hold on, Dan, what about Blazor Server? Blazor Server has this WebSocket connection that it's using, and it's running server-side. And yes, that is all true. But we try to keep the component model agnostic to the hosting model. Like where you're running your components shouldn't change how you write those components. So we actually try very hard to make it so that the HTTP context shouldn't be a concept in your component code at least. Whether when you're running in a Blazor server application. So that's why. If you're like, I want to get access to the HTTP context, why can't I do that? Well, it's because you're really conceptually writing client-side code. Now, there are things you can do in Blazor Server and in Blazor WebAssembly where you want to get something from the request context and flow that into your application, like flow that into your client-side logic. And there are patterns for doing that. Like in your host CSHTML file, that's where you can get the HTTP context. Like a CSHTML file is executed in the context of a request. So grab the context there, extract all the stuff you need out of it, and then use normal component parameters to flow that data into your application, into your components. That's the way we would recommend doing that.
And there's not really any any requests happening, because in the case of Blazor server, everything is going over SignalR, so there's only one request.
It's all hub invocations at that point. Yep. But if you need some context from that broader WebSocket connection that was originally established, the way you should do that is by plumbing it through the host CSHTML file.
Can you also jump between controllers and pages like in MVC?
Can you jump between controllers and pages? I'm not trying to guess what that one is referring to. You can, things that you can do. You can have Blazor components that get rendered from pages and views, from Razer pages and MVC views. That's what we saw earlier with the component tag helper. Blazor has its own client-side routing engine, so that if you want to intercept browser navigations client-side and route those navigations to components to be rendered, you use the Blazor client-side router. If you want to then link out to some other page, like a Razer page or an MVC view that's at a different URL that's not part of the set of client-side routes, you can absolutely do that. We don't have any like link generation features for doing that, but you can still set up the, put in a normal anchor tag in the URL for going to those pages and views. Absolutely. I'm not sure if that's exactly what you're asking, but those are things that are possible today. All right, I gotta show Maui. We have to get to the Maui. Last little thing I didn't get to show yet. This is a brand new feature in Preview 6. Is also required component parameters. Like if I want to say that this title is required, we can, of course, F12 to go to definition, and we can put this new editor required attribute on the parameter. Save that. And then if we go back to index.razer, so here we have an instance of my survey that has the parameter, but if we add another one, my survey, and we don't put that parameter on there, we're going to get a nice design time warning letting us know that we're missing a required component parameter. This is purely a design time feature. There's no enforcement of these parameters having values at runtime. Like we're not doing runtime checks to see that the title really have a value and was it not null. But this can be a nice usability improvement if you have components that have parameters that really need to be specified. So that's a new thing as well. Okay, now
is it possible to say that I want these two parameters or I want these two parameters?
No. yeah. Getting the current feature is very scoped to a single parameter that you want to say is required. We did have some discussions about like you get into like data annotations, right, where you can do all sorts of fancy, like I want to validate that parameter was set, or if that thing was set with this value, that one's going to be set. That's logic that you'll we don't have a declarative model for doing that currently.
Yeah, fair enough. Fair enough.
Okay, so what is .NET MAUI and what are we doing with it in Blazor? Let me hop back to the slides real quick. That's not right. This one. Okay. So everything we've seen so far was a web application. Like, right, these are things that are running in the browser, but sometimes building a web application isn't enough. That's getting rarer and rarer these days, given how rich and mature the web platform has become. But sometimes you need full access to the native capabilities of the underlying device. We have lots of ways of writing native apps with .NET. WPF, Winforms, Xamarin, and the new and up-and-coming .NET MAUI. With Blazor, we think that one compelling way to write a native application is to write what we call a hybrid application, where you use a mixture of web technologies and native to get what you want. This makes a lot of sense if you have existing, like say Blazor code or web-based code, HTML, CSS, and you want to reuse it in a native application. Maybe you want to have a very consistent look and feel across your website and your native apps, or you just want to use your skills. Like you're a Blazor dev, you know how to write Blazor code, you don't know this XAML stuff. How can I write a native app cheaply and quickly using what you already know? A hybrid app approach lets you do that. So we think this is a very compelling way to do native app development. is using this combination of web and native. And basically what you're doing is embedding a little browser, a little web view control inside of a native application so that you can do HTML, you can do CSS, while still having full access to the native capabilities of the device. In a .NET application, we think this looks something like this. You have a native app shell, you have a web view control in that native application, and then you have your .NET code running directly in the native app that is running Blazor components locally. There's no server happening here. There's also no WebAssembly. We're just running components in using .NET like you would run any .NET code in, say, like a Xamarin or MAUI application. And then we just push the DOM updates into the WebView control. Any UI events that happen in that browser control, they get pushed back out into your .NET code and you handle them locally, all within the application. It runs fast. Anything you want to do with the underlying device, you can just do using normal .NET APIs, using the .NET platform. So that's what we call a hybrid app with Blazor. And we've been working specifically with our friends on the .NET MAUI team to enable Blazor hybrid apps with .NET MAUI. .NET MAUI is our new multi-platform app UI framework where you want to write user interfaces that can work on desktop and mobile, Windows, Mac, iOS, Android, using primarily native UI controls. .NET MAUI is like you can think of it as the logical, the successor, the evolution of Xamarin Forms, but expanded to more platforms, expanded to desktop, and also with an updated and modernized architecture. What we've done is we've worked with the MAUI folks to create a Blazor WebView control that you can host inside your .NET MAUI apps, on mobile apps, on desktop apps. We're primarily focused on desktop in MAUI 6, but mobile apps are absolutely supported and they do work. And what this allows you to do is reuse existing Blazor components untouched in a .NET MAUI app and light up those components with native functionality. Let me show you what I mean. We'll do a quick demo. So I'm going to open up an existing MAUI application that I've got here. This one. Okay. And I'm going to, let's go ahead and just run this. So I'm going to run this first on Android. Actually, come on. Light up the, it's because I've got the wrong startup project. This one, I want to run this on Android. And this is the part whenever you're doing mobile app development demos where you talk for a little while the way to the emulator. All right, so this is a MAUI application, and you can see this looks like a normal Blazor app. I've got a couple extra things that I've added in here. And it is literally the same code as you would have in a Blazor application. Like if we look at the counter component, we have a counter.razor file in our MAUI project, and it's just HTML and normal Razor syntax that we're running inside the MAUI app. But it's running natively. It's running native in the native application, and you can compose it with things like native UI. Like up here at the top, you can see there's this this is so native label. That's not part of the Blazor part of the application. That's actually done with like a native XAML-based control, like a native label. So here's what the UI actually looks like in the implementation. So we've got a stack layout. That's native components. We've got a native label control. That's all .NET MAUI native controls. And then we have a Blazor WebView control, which is also a native .NET MAUI control. It's just a web view that knows how to host Blazor components inside the application. We point it to our HTML file that we want to use as the root HTML of the application, and then we point it to the root components that we want to render within that app. In this case, I'm pointing to this component type main, and that's over here in main.razor. If you've ever seen a Blazor app, that looks like app.razor in every single Blazor app that's ever been created from the project templates. This guy is then just routing to these other routable components up above, index and fetch data and counter. All right, so we can get a mixture of native UI and web UI all within the same application, like the things like the counter just work. We click the counter, that goes up. We got fetch data, that all just works. This is mobile. we can also see the same application running as a desktop application. This is going to use the new WinUI support for Windows. So I'll go ahead and get that up and running too.
What about JavaScript interrupts and stuff like that? Would that work here as well?
Same model, yeah. So just like in any Blazor app, when you use the IJS runtime abstractions to basically tunnel JavaScript calls into whatever JavaScript runtime you're interacting with, you can do the same thing in a .NET MAUI Blazor application. Nice. We're basically setting up a little interrupt channel locally between your Blazor components and the Blazor Webview, and we'll tunnel the JavaScript calls across that little interrupt channel. It's like Blazor server, really, but instead of it being across the internet, it's all squashed into a single call. That's the way you can think about it. Okay, so we got the same UI, exact same code being shared here in a native desktop application. We got our native WinUI label this time instead of an Android label, but then our HTML and CSS. And this button is fun. So this is showing how you can do anything here. Like sky's the limit. You want to touch an API that does fun stuff with the underlying platform, you can. I'll show you the code for this button. You probably saw it earlier. So we've got a button with an on-click handler that's going to call get message. And then here we're like creating a temp file on disk. And we're going to like write stuff to that file. And then we're going to launch Notepad because we can launch random processes with this model. It's running locally on Windows. And then we'll read out whatever the user typed into that file. So let's see that working. So we can click on this. There, we just launched Notepad from a Blazor application. And we can put coding after work box. And we'll save that and close this, and then read in that file from our Blazor components all within that application. So you can do native functionality, anything you want. We have a pretty nice sample that I have on my GitHub account that's a weather application. I'll just close with that. That's this guy.
When we're talking about Blazor server, we can do like direct SQL calls directed to a SQL server, for example. Would that work here as well?
So the Blazor code here is running on the device. Like it's running in that mobile app on the mobile device, or it's running on my Windows desktop machine on this device. If you had a SQL database on your local machine, or I guess like if you're asking, can I open an arbitrary connection to a SQL database someplace that I have access to? Yeah, you can. Cool. Arbitrary network connections, sockets, anything that the device can do, you can do with this model. Yep.
I wasn't expecting that.
I'm not. I don't know if you should be opening up direct database connections.
That's a completely different show.
So
stuff you really shouldn't do.
Here's an example of how you can reuse code, Blazor code with native applications. Like this is a web application. This is I think this is Blazor server. So we can like click on things. We can see the current weather in Boston. We can look at some like favorite locations. This is pulling down some weather data from Azure. Let's go check out the weather in South Korea. We can like change from imperial units to reasonable, rational units. So that looks good. So that's a web application, and all the components for this web application are implemented in a common library. This Blazor Weather library is referenced from our Blazor Weather.server project. If we look in like where is it? Yeah, projects. Yeah, Blazor Weather. So there's the project reference, and all my components actually live in here. Like I have all the logic for the Blazor app is in this one library, and we can now then share those same components with a .NET MAUI application and get exactly the same UI to show up. So here's let's do WinUI first. Okay, so here we have now a native desktop app using exactly the same UI as my web application. All the same functionality works, but we can, of course, now light up native things in this app that we couldn't do otherwise. Like you may have noticed down here at the bottom, it's kind of small, but there's this little .NET bot that just showed up in my system tray. We're interacting with the system tray from this desktop version of the app. We can trigger like native notifications from this app. You can do some of that stuff from the web, but like system tray integration, I don't believe there's a web API for doing that. And then of course we can do mobile. So let's set this as the starter project and let's fire up the app in the Android emulator. previous app. So here we have one set of components that are running on Android. There's the app. It's got a nice responsive design on desktop and on web. So that's .NET MAUI Blazor apps. That's also coming in .NET 6. Yeah. Any questions about that?
Amazing. Well, we got a comment. It's beautiful.
Yeah.
It is
Agreed.
beautiful.
It is. It is.
I happen to know that gentleman. That's one of our illustrious dev leads on the .NET MAUI team. Hi, Jonathan. Jonathan and his team actually did a lot of work to help out with this application. So he may be a little biased. But
he isn't wrong.
He isn't wrong.
He isn't wrong.
So we got a couple of comments talking about Blazor mobile bindings earlier.
Mm-hmm.
Why would I even want to use that when we have this?
So for the most part, this is the productization of mobile Blazor bindings. If you haven't heard of mobile Blazor bindings, that was an experimental project that we kicked off, I don't know, about a year or so ago, where we were playing around with a lot of these concepts, like building hybrid apps. It was based on Xamarin at the time, because that's what existed. But same idea, Webview inside of a Xamarin app, hosting Blazor components directly in the application. All of the hybrid concepts for mobile Blazor bindings are being productized here with .NET 6, .NET MAUI. There is a piece of mobile Blazor bindings that is a little extra, a bonus. In mobile Blazor bindings, there was also a model for you to author native UI controls, like that native label. Instead of that being in XAML, it enabled you to do that in Razer directly. Like have basically Blazor components that wrap the native controls that you could then interact with using Razer files. That part's not coming to .NET MAUI in .NET 6. Maybe it'll come in a future release. Planning for future releases is just now getting started. So that part will still stay in mobile Blazor bindings for now. What we expect to have happen is that the Webview, the Blazor Webview in mobile Blazor bindings will be swapped out for the MAUI one. Mobile Blazor bindings will be updated to be based on MAUI, and then the native control stuff will stay in that project for the time being.
Fair enough.
Yeah.
And if there's any WinForms and WPF devs out there who are wishing that they could get some Blazor action, we also have Blazor Webview controls for WinForms and WPF. It's not just for MAUI. The model is fairly generic. It's not specific to MAUI. I have one last project that I'll show here. This is a WinForms app running on .NET 6, where we added a Blazor Webview control to the WinForms app. So there's a Blazor Webview control. It's not the MAUI control, obviously. This is a Windows Forms control, but we can run this and have this is again a Webview control hosted in the WinForms app this time, where you can use Razer HTML and CSS to write modern UI inside of a WinForms app. Same thing for a WPF app. We have one there too. Why do we have these things? Well, if you're building these applications, if you have legacy WinForms WPF apps and you're looking for a path to modernize, one option you might consider is starting to write your, any new UI that you want to build, write it as Blazor components. Use a Blazor Webview control inside your existing desktop app, and then when you're ready to move to MAUI as a modern stack for getting to mobile, getting to Mac, getting to other platforms, those components just move as is without you having to change anything. So this is a potential modernization path for people that are interested in taking existing desktop apps and getting them to MAUI and Blazor. And web at that point as well.
Can you force releases or updates to clients with MAUI?
So the deployment model, I think that's asking, how do I ship my app after I've built it? I'm guessing is what that's about. That depends mostly on the platform that you're dealing with. Like you can ship MAUI apps to the app stores and ship updates that way. With WinUI on Windows, they use MSIX extensively right now, so you can use the MSIX model for delivering your app and delivering updates. We are trying to see if there's some things we can do to simplify deployment of MAUI apps. Like there's some tech that was built for Electron apps. I think the project's called Squirrel, that is used by a lot of Electron apps for shipping the apps, packaging, dealing with auto updates and those types of things. there is some efforts that we're looking at internally to, like, could we have a technology like that we can make available to MAUI developers too? But all the existing packaging and auto update technologies that are already there, they will work with MAUI as is.
Nice. I actually thought that the AOT was the thing that I'm going to be most excited about, but I'm equally excited about the app building. I can build apps.
You can.
There's a modernization. I wanted to just get the schedule up so people who aren't familiar when we're shipping. November 2021 is when everything is coming. And then from then on, it's a yearly cadence. This release is an LTS release, so long-term support for .NET 6. That includes Blazor Server, Blazor WebAssembly, .NET MAUI, Blazor apps. .NET 7 should come in November of 2022. That will be the next current release, and just a new release every year. So even more stuff coming in future releases as well. Who knows what the future may hold?
We're looking forward to it.
Mm-hmm.
Great.
Absolutely. And we will talk more about Blazor next time, I think.
Yep.
Because next week we're continuing to build on our website because we have decided to rebuild it from scratch using Blazor.
It's time.
It is time. It is time. Currently, it's just a bootstrap thingy.
Yeah.
We haven't done anything.
And I've heard that you are taking over the CSS part.
You are putting the CSS part in my lap is
So
more
I
like
said
it.
and it went out my mouth, in my ear, so I heard it. This is what happened.
And it's now on internet.
It's on the internet.
Yeah, but we did have some really good CSS talk with Ed Shabanar, yeah. There's a lot of stuff happening there too.
Are you guys going to try and use .NET 6, do you think? Or do you think you're going to stick with .NET 5 for the rewrite?
So when we started this, we're on episode 3 of this already, I believe. It's going to be the episode 3.
Yeah, we only did 2.
And at that point in time, I was just about to have a class, to hold a class with .NET 5. So I wasn't prepared to risk it to install .NET 6. I know.
But it is a couple of months ago.
It was a couple of months ago, yeah. But maybe it's time for an upgrade.
Yeah, and then we can see how we would migrate that stuff. Mm-hmm. I'm guessing it's not that big of a job.
Next, finish.
Yeah.
Change some packages and you're done.
It should be. That's the way it should be. I mean, there are some rough edges, obviously, right now with .NET 6. It's still in preview, so keep that in mind. But as we get into the release candidates coming up here soon, things should get stable very, very fast. And that might be a great time to make the move. You start with .NET 5, and then when a release candidate comes out, so let's try .NET 6.
And I actually just installed Windows 11 on my demo machine.
Yeah.
And I have Visual Studio 2022. So
you are prepared, and you don't care about release candidates.
Fails.
Yes, definitely. But I don't think we actually need to wait for the release candidate because it's just our own page, so it doesn't. It's not a client that will get angry if something doesn't work.
It's a little bit like Ivan Drago. If he dies, he dies. Kind of like that. Doesn't matter.
You got a Rocky reference here too.
I know, right?
Yeah. That's fun stuff. Yeah, we're looking forward to .NET 6.
Thank you so much for joining us. It's been so much fun.
Yeah, definitely.
Thank you for having me. Thank you for patiently watching through all my my stumbles in the demos. Things are there's lots of fun stuff to play with. Obviously, there's great things to get feedback on as well. So as you try out the bits, let us know about things you like and don't like on GitHub. Just file issues, and that's tremendously helpful in helping us land a really solid and high quality release this November.
Yeah.
Awesome. So much looking forward to that.
And we got a lot of thank yous, and thank you as well. Exciting.
Yeah.
The chat room is excited too.
We are. And I will do a shameless plug.
Oh.
but for you.
For me.
So maybe
What
it's
have I done?
shame. You have done a book.
I have done the book.
You have done a book. You should show your green screen
My
book.
green screen book. Look at this.
It's finally
transparent.
out. It's finally out.
I actually got this, I believe it's like 2 days ago. I've seen on the internet, on Twitter, people like, oh, I just got the book. And I'm like, I don't even have it.
Yeah, that's... Oh, we do have a quick question here. Where do we find more information on ahead of time?
Docs are coming. They're in the works. The blog posts are probably the best place to start right now. So check out the blog post on the ASP.NET blog. So devblogs.microsoft.com/ASP.NET. Just look for the .NET 6 related release announcements. Pretty soon we should have official documentation documenting WebAssembly AOT, runtime relinking, and some other stuff that's coming as well, like support for linking in native dependencies in the next month or a month or two in the months ahead. Certainly by the time we get to November.
Awesome. So let's end the stream then.
Let's end the stream. Yeah, I'm busy in the chat room here. Because Stacy said that we should definitely check out the book. It's awesome. So thank you for that. And thank you, everyone, and hope to see you next week as well.
Yeah. Bye.
Bye.